Hello everyone, welcome back Physics for AP channel. So today is the most important topic, that is today we are going to discuss how to draw the ray diagrams. So in our previous part we have learned about the rules for drawing the ray diagrams for the concave and the convex mirrors, and today we are going to implement that. And while implementing we need to follow few of the instructions before drawing the ray diagram. So before that, take a pencil, paper, a protractor, a compass, scale, everything. Keep everything with you. And now listen carefully. Before going to the ray diagrams, you have to follow the instructions. Is before drawing the ray diagrams, first of all, draw a principal axis. First of all, you need to draw a principal axis with a scale. Then after that, with the help of a compass, you need to draw a curved path. So you need to take a compass with a centimeter. You take it as 4 centimeters. So if you want a diagram for smaller one, you take it as 4. Otherwise, if you want a bigger one, you can take it as 6 centimeters. So keeping at a point, based upon a point, you need to draw a curve like this. So actually, I don't have a compass. I'm drawing with my hand. So you need to point at a principal axis, and you need to draw a curve. Now, the point where you have kept is considered to be as a center of curvature, and the point where it is intersecting to the principal axis is considered to be as a pole. And if you have taken 4 centimeters, that is from here to here, if you have taken 4 centimeters from pole to the focus, you need to take 2 centimeters. That is considered to be as a focus. Otherwise, if you have taken the radius of curvature as 6 centimeters, you need to take the focus for 3 centimeters. Okay, so that is, it should be exactly half to the radius of curvature. That is, if you have drawn the pole from the center of curvature as the 4 centimeters, from pole to the focus you need to take as a 2 centimeter. That should be exactly, and the curve should be based upon the center point what we have taken. So my suggestion is to take the 4 centimeters of a compass, take it 4 centimeters, and with the help of a compass you need to draw it. So as shown over here, the help of a compass, at the point where you have kept is taken as a center of curvature. So it will be at 4 centimeters, and the half of it, that is from this point to the focus, is taken as 2 centimeters. So this is what you need to draw for a concave or convex, whatever we do. So convex, we don't need some exact calculations, but for concave mirrors we have 6 ray diagrams, and 6 ray diagrams should be exactly the exact positions what we need. So let us go into the ray diagrams. So let us go for a concave mirror, that is the ray diagrams for a concave mirrors. Now, all I previously have prepared here. So this is the ray diagrams for a concave mirror, and the first one is when the object is at infinity. So when an object is at infinity, we get a parallel rays. So when an object is at infinity, we get a parallel rays, and those parallel rays will be considered as like this. So all the parallel rays will be considered as like this. So this is another parallel ray, another parallel ray, parallel. So all they are incident on a concave surface. So as we know from the rules for drawing the ray diagram, any rays which is passing parallel to the principal axis passing through the focus. So all these rays will be passing through the focus. So all they meet at a point, and that point is said to be as a focus. So this is the first ray diagram. So the image is formed So image is formed at focus. So the type of image we form here, it is real image and inverted and highly diminution. So these are the characteristics of the image, and let us move on to the second one, which that is when the object is kept beyond C. So when the object is kept beyond C, let us see where the image is formed. Beyond C. So this is the beyond C. So this is the object. So you can take it as a little bigger one. So when the object is kept beyond C, let us see where the image is formed. So the first ray should be parallel to the principal axis. And when it is parallel to the principal axis, it passes through the focus like this. And the second ray should be passing parallel to the principal axis. The second ray should be passes through the focus. When it passes through the focus, it passes parallel to the principal axis like this. It should be exactly parallel. Now if we see here, this is the incident ray and this is the reflected ray. And this is the incident ray and this is the reflected ray. We get an intersect part over here. This intersect part forms an image, right? And here we get an image, that is the object O. So when the object is kept beyond C, the image is formed. So the image is formed between C and F. So the image will be a real image. So it will be inverted and it forms a diminution. So what do you mean by diminution here? Diminution means a small size. If you observe the size of the image over here, you can see it is very less size. So you can draw like this neatly as what I have said first. So these are the first two cases when the object is kept at infinity, when the object is beyond C. So let us move on to the next case. So when the object is at C, at the center of curvature, this we need to make little bit practice over here because we need the exact intersecting point at the C. So consider this is the image is at the C. So same as usual what we have said, first it is passing parallel to the principal axis and it is passing through the focus, and the second which is passing through the focus, it should pass parallel to the focus. So actually the image should be formed over here. The image should be formed over here. So if we have taken the calculations correctly for the curved path, the intersecting part, whatever the intersecting part over here will be exact at the C. So you need to take the exact calculations over here. Otherwise, if you draw with your hand, you won't get the exact intersecting point, just like what I have done here. As I have done with my hand, so I didn't get the exact calculations over here. So let us see for the next. Let us do it again. Let us try it. So first I have drawn a principal axis, and next I have drawn a curve. So this is a concave mirror. This is the focus and this is the center of curvature. Remember that exactly half of the center of curvature should be the focus, and this is the pole. Now assuming the first, the object is kept at C, parallel to the principal axis, passing through the focus, and second passing through the focus, passing parallel to the principal axis. So now if you see here, I am slightly near to the center of curvature, slightly near to the center of curvature. But if you have taken the exact curve, then you get the exact intersection at the center of curvature over here. That will have an exact center of curvature. So here you will get the center of curvature. The image will be formed upon the center of curvature here. So all you need is you need to draw exactly with the help of a compass and a scale with taking correct measurements. So what will be the nature of here? Here it is. The image will be formed at C itself. The image will be a real image. It will be inverted, and also it will be in same size. There will be no change in the size, so it will be at the same size over here. And next, the object is placed between C and F, that is between the center of curvature and the focus. If we assume here the object between C and F, first it will be passing parallel to the principal axis, passing through the focus, and second it will be passing to the focus. So we need to draw the curve little bit near. So whatever the curve you are taking here, it should be in a perfect and neatly. It should be drawn neatly over here like this. And the line which is passing through the focus will pass parallel to the principal axis, and there you can see the point of intersection over here. So here the point of intersection will be beyond C, that is the image will be formed beyond C. Again I am noticing you that it should be the calculations, the measurements what you are taking, it should be exactly correct. Then only you will get the correct images over here. And here the image is formed as the real image. It is inverted as the image is reversed, and here we get the size as a enlarged. Why? Because the size of this is the object and the image has been increased. So as the image size has been increased, so it can be, we can say it as an enlarged over here. And next, going into the object when it is kept at F. So when the object is kept at F, that is at the focus, the first ray should be parallel to the principal axis, passing through the focus, and the second ray, when it is incident on the pole, here also it will get reflected. So as these two rays are parallel to each other, so the image is formed at infinity. So the image is formed at infinity. So here the image we get here is real image. Here it will get as inverted, and the size of the image will be highly enlarged. That means we cannot see, as it is very highly enlarged. And the last case for the concave, that is when the object is placed between pole and focus. So here when the object is placed between the pole and focus, so here I kept the object. So when the object is kept between the pole and focus, as usual the first light ray should be passing parallel to the principal axis, passing through the focus, and this ray should be extended over here, and the second ray passing incident on the pole, and it gets reflected here like this, and again this reflected ray has been enlarged, and here we get the intersecting part here, and this intersecting is nothing but we get an image. So this is the image, this is the object, Remember that while drawing the ray diagrams, you need to definitely draw the arrow marks over here. The arrow marks are very important whenever you're drawing the ray diagrams. Arrow marks are very important. So while drawing the ray diagrams, you need to keep in your mind that you need to identify the arrow marks, and also you need to identify the object and also the image. Okay, so whatever you're writing over here, the drawings, or you need to indicate the C, you need to indicate the F, you need to indicate the P, the arrow marks of the incident ray and the reflected ray, and also the object and the image indications. So this is the previous image for the fourth case when the object is present between C and F. So this is the exact point. I have made little bit corrections over here. And let us once revise from first. So when the object is kept at infinity, all the rays are incident and gets converge at a point. So that point is nothing but we call it as a focus, and the image is formed at the focus. So the image is a real image, inverted and highly diminished. So when the object is beyond C, so beyond C, here the first light ray parallel with the principal axis passing through the focus, second passing through the focus parallel with the principal axis, where the image, where the reflected rays are intersected, there we get an image over here. The image is formed between C and F. The image is real image, inverted, and we get it diminished. That means this image size will be decreased. And next, when the image is at C, so when the image is at C, it passes parallel to the principal axis, passing through the focus. The second one passing through the focus, passing parallel to the principal axis, where we get intersected, where the reflected rays are intersected, there we get an image. So again I'm saying that when we are drawing the ray diagrams, you need to take a perfect measurements, then only you will get the perfect diagrams here. So the image is formed at C, so the image is real image, inverted, and we get here it is same size. So when the object is placed between C and F, that is between the center of curvature and the focus. So here the first passing parallel to the principal axis, passing to the focus, and the second one passing to the focus, passing parallel to the principal axis, where the reflected rays are intersected, we get an image over here. And if we see the size of these two, so we get here the enlarged, that is we get an enlarged image here. So that the image will be beyond C, the real image, and we get an inverted and the enlarged. So just now I told you we need to indicate the image and object definitely. Okay, don't forget it. So while drawing the ray diagrams, don't forget to indicate the real, that is the object and image indications, and as well as the arrow marks also. Okay. And next, the last case. So when the object is at F, so we get an infinity image, real image, inverted, highly enlarged, and the object is between P and F, so that is between the pole and focus. So these two rays will never intersect. So these reflected rays are being extended, and those extended reflected rays get intersect. As a result, we get a virtual image over here. So the image is formed behind the mirror. So the image is formed behind the mirror, and the nature of the image will be virtual image, and we get an erected, that is an upright image we get over here, and the size of the image will be enlarged. So if we see here the object and the image, we can compare the size over here. And next we are going for the ray diagrams for the convex mirrors. So for the convex mirrors, it is just only we have only two. That is, the first one is when the object is placed in front of the convex. So in front of the convex means anywhere you can place. So I am placing it over here. This is the object. the first one is passing parallel to the principal axis. What do you have to do? It will pass away from the uh, convex mirror as it appears to be coming from the focus. So as it is been appearing to be coming from the focus, and the second ray should be incident at a pole. The second ray should be incident at a pole, and it gets reflected with the same angle of reflection, the same angle of incidence we get here. So this reflected rays has been intersected over here, and if we see here, we get an image over here. These two reflected rays are being intersected, and we get an image over here. So where the image is formed is, so image is formed always in front of focus. Always the image is formed in front of the focus, and the nature of the image is virtual image. If the image is virtual, then it is erected, and if we see observe the size, it is diminished. It is diminished. And if we see in the case of when the object is at infinity, so when the object is at infinity, just I am taking two light rays, so it bends away, it gets diverges. As these diverges are coming from the focus, that is the image which we get here is the virtual image which appears on the focus. So here we get at focus, the image will be virtual image, and we get what the size here is highly diminished. So this is the ray diagrams for the convex mirrors. So keep in your mind, again, you need to draw, if you want to get exact ray diagrams, you need to take the measurements. So this is the convex, you have kept in front of the mirror. If you pass parallel to the principal axis, it gets diverges over here, and if you extend it, you will get which is passing through the focus, and the second which is passing through the pole, and then it gets reflected back, and this reflected ray has been extended. Here we get an intersecting point over here. That intersecting point provides an image over here, and same as for the object which is at infinity also. So same as when the object is at infinity, the image will be formed at focus. So here the image which is formed is, here it is the virtual image. So these are the ray diagrams which you need to learn carefully, and you need to practice very well. The same ray diagrams will be come again in the 6th chapter. In the 6th chapter, I will be explained very neatly over there. And next, coming to the uses of the convex and concave mirrors. So these are the very important. So what are the uses? It's very important. So uses of concave mirrors. So, and another one, uses of convex mirrors. So where we are using this convex mirror and concave mirrors, let us see here. So in which cases we are using, where we are using. So the first one, concave mirror, it is used in car headlights. So it is used in the car headlights, or we can say it as a torch lights also. We are using in the torch lights. So why? Because here the object is present at the focus, which gives a the image which is present at the infinity. So that is when the bulb is present at the focus, so the light incident on the mirror and gets at the parallel, that is at infinity we get here. So that is the concave mirrors are used as a car headlights and as well as a torch lights. And second, these concave mirrors are used by the ENT specialists. They are the ENT doctors. So whatever you get any problem with our teeth, they use the concave mirror. So at this case, what they are using here, it is they are using the case between P and F. Why? Because between P and F we get a virtual image. So the virtual image will be formed inside the mirror. So real image, if we get a real image, we definitely need a screen or a white paper. So here the ENT doctors use the concave mirrors and they place it between the pole and focus. They get a virtual image which can be seen inside the mirror. So and the concave mirrors where we can use. So another point, the concave mirrors. So the concave mirrors are used to burn papers. So the concave mirrors are used to burn the papers, and also they are used as a TV dish antenna also. TV dish antenna also they are used to the concave mirrors, so the concave surfaces are being used over here. And coming to the convex mirrors, so these convex mirrors are used in street lights. Why we are using street headlights? Because for convex mirrors they are being diverging. So we need a diverge of light. So if we want to need a diverge of light, so for definitely we need a convex mirror, as the convex mirrors are diverging mirrors. And second, they are using in ATM centers or ATMs, automatic teller machines. So in the ATM machines, whenever we want to take money, we can see a mirror in front of it. So that mirror is nothing but we call it as a convex mirror. So why? Because it gives a field view. Field view will be more. So we can see the complete ATM room, who is behind us, who is the side of the ATM. So we can completely view it. And third one, it is used as a rear view mirrors. So rear view mirrors are the side mirrors. That is, whenever we are going in a vehicle, we have a side mirror over here. So in that side mirror, we can see any car or vehicle coming back of us. So why? Because to avoid the accidents, we use a convex mirror, as it produces a large field view. It produces a large field view. So due to that, we are using a convex mirror. Okay, so we don't use a concave. Why? Because a concave produces a low field view, but for a convex, it produces a very large field view. That is why we are using a convex mirror over here. Okay, so these are some of the examples for the concave and the convex mirrors. So if you want the more information about these mirrors, you can type in the internet or you can search in the reference books. Okay, so I have presented you some of the uses of the concave and the convex mirrors. Okay, so today we have in this video we have discussed about the ray diagrams for the concave mirrors, the total 6 ray diagrams, and the convex mirror for the ray diagrams for the convex mirrors, they are 2. And we have discussed about the uses of the concave and the convex mirrors. So these are also the very important for the exam view, because they ask where we are using the concave mirrors, where we are using the convex mirrors. Otherwise they may ask like this, where we are using the spherical mirrors. So for that we can write all these points over here. So it can be convex or concave, whatever we can write it as everything over here. Okay, so thank you very much, and please subscribe the channel. And next video we will go for the derivation part of the mirror formula and the magnification, and also we will go on through the problems. Thank you very much.